We need to know how to use the Ncr function and how it relates to the Pascal's triangle. So here's a function where you use a value for n and a value for r, and you get different outputs. Now another way of writing Ncr, or the way we say it, is n choose r. So another way of writing is n r like this. Okay, so when we're doing algebra, you might find it more useful when you write it like this. Now I'm going to use a specific examples for this, and I'm going to use this row here. So this is our fourth row. Remember that this is our row number 0. This is first row, second, third, and fourth row. Now to use this, you need to know the factorial operation as well, and I will show you what that is. Okay, so just quickly, I'm just going to show you how this relates to this row here. So if I was to have n as 4, so 4CR would give me all of these values. It would give me 1. It would give me 1 when I use R as 0. Okay, and when I use R as 1, I would get 4. I will get 6 when I use R as 2, and then if I use R as 3, I'll get 4, and if I get R as 4, I'll have 1. So the value of I'll write it using this notation now. So the value of 4 choose 0 is equal to 1. The value of 4 choose 1 is equal to 4. The value of 4 choose 2 is equal to 6. The value of 4 choose 3 equals 4. And the value of 4 choose 4 is equal to 1. Okay, so notice how this function directly it links to the Pascal's triangle. Now, I'm going to show you how to actually get these values just using the function. So for example, we might be asked to use the 7th row, and it will take us very long to write out the 7th row of Pascal's triangle. So we need to know how this function works on its own. So this value here, 1, you can get like this. So I'm going to use this notation again, 4C. So I'm going to use 4C0. So 4C0 is equal to 4 factorial over 0 factorial times 4 take away 0 factorial. Okay, 4 factorial is defined as 4 times 3 times 2 times 1. Okay, so this would be 4 times 3 times 2 times 1. 0 factorial is just 1. Here we've got 4 take away 0, which is 4, and then I'll have 4 factorial again at the bottom. So I would have 1 times 4 times 3 times 2 times 1. And you can see that in this fraction, all of these will cancel each other out, and I'm just going to be left with 1. I'll use this one now, 4 choose 2, and this time I'm going to write it using this notation. So if I had 4 choose 2, this would be 4 factorial at the top, where the 0 is, so the 2 factorial here, and the 0 also is there, and the 4 is also there. I'll have 4 take away 2 factorial as well. So I will have 4 factorial over 2 factorial times 4 take away 2 factorial. So if I was to write this one out like this, this would be 4 times 3 times 2 times 1. This will be 2 times 1. 4 take away 2 is 2, so this will also be 2 times 1. So I will have, this will be 4 times 3 times 2 times 1. I will have 2 times 1 times another 2 times 1. Okay, here I have 2 times 1 because 4 take away 2 is 2, and 2 factorial is 2 times 1. Now I can see that some values will cancel out. So here's the 2's that will cancel out. 1's, anything multiplied by 1 is just 1, so it's there. And here I'm going to have 4 times 3, which is 12, over 2, which is going to give me 6. So this is going to be 12 over 2, which is 6. and we saw that 4 choose 2 was 6 in the Pascal's triangle as well. Okay, so this is the link between this function Ncr and the Pascal's triangle. Now that we've seen the link between the Pascal's triangle and the function n choose r, I'm going to rewrite these values using the Ncr function. Okay, so just so that we can see what it would look like. So here, remember this was the fourth row, so n is 4, and for the first value n choose 0. So I will have n 0, so I'm going to use 4, 4 0, and then a to the power of 4, and then here I'm going to have 4 choose 1, a to the power of 3 times b. Then I'm going to have 4 choose 2. Remember, just now we saw that 4 choose 2 gives me 6, so I've just replaced the 6 with 4 choose 2 here, just to show how the Ncr function works when I'm expanding the power of a binomial. So this would be 4 choose 2 a squared b squared plus 4 choose 3 a and b cubed plus 4 choose 4 b to the 4. Now the reason why I did this is so that I can now go to a more general form, and this time instead of using 4 here, I'm going to make it all in general terms. So I'm going to have a binomial, the general binomial a plus b, and I'm going to power it to the general number n. Okay, so I'm going to have a plus b to the power of n. Okay, so a plus b to the power of n, what would the expansion of this look like? So now that we've made it general and we have a function to find these values, we can actually take the value of n to a very large number and easily find what the coefficients will be. So I will just start writing this out and we'll see how it ends. So this is going to be n choose 0, and I will have a to the power of n. Okay, so that's the first one, a to the power of n and b to the power of 0. Then I'm going to have n choose 1, and notice how the power of a decreases by 1 and the power of b increases by 1. So I will have a to the power of n take away 1 and b to the power of 1. The next value would be n choose 2, and here I'm going to have a to the power of n take away 2 and b to the power of 2. Okay, and this will carry on like that. Remember we said we want to know for even very high values for that, so this will carry on all the way up to, so let's say it goes all the way up to n choose n, and I will have a to the power of 0 at this point and b to the power of n. Okay, so this is the general expansion of the binomial using the binomial theorem. So this is also called the binomial theorem. It's the general expansion of a binomial raised to the power of n. This is a specific binomial that we need to know the expansion of. I'm just going to use the binomial theorem to expand this and then simplify where I can. So we will have n choose 0 times 1 to the power of n and x to the power of 0 plus n choose 1. This time I'm going to have 1 to the power of n take away 1 and x to the power of 1 plus n choose 2 times 1 to the power of n take away 2 times x to the power of 2 plus all the other terms, and then the last one's going to be n choose n times 1 to the power of 0 and x to the power of n. So in this case I know that n choose 0 is 1, 1 to the power of n is 1, x to the power of 0 is 1. So this first term is 1. I will have 1 here plus, now n choose 1 is n times 1 to the power of anything is 1, and I'll have x to the power of 1, which is x. So I will have n x, Next one, I've got n choose 2. Now, I may not know this one. Times 1 to the power of anything is 1. And then I'll have the x squared. This one, I'm going to write it out using the factorial. So I'm going to have plus. Now, with the factorials, I'm going to have n factorial here. I will have 2 factorial. And I will have n minus 2 factorial. Okay, so that's what I would need to do to work this one out. Then I'm going to get times that by x squared. And then all the other terms, you can see what the pattern kind of looks like. When I have a power of 2, this is what this would look like. I'll have an n factorial over 2 factorial times n take away 2 factorial. And the other powers will be similar like that as well. Last term, we will have n choose n is 1. 1 to the power of 0 is 1, and just x to the power of n. So the last term would be x to the power of n. Now, one way they like to use this is they like to use very small values of x. And then what you will notice is that when you take a very high power of a small value, small positive values, for example, if x was 0.01, 0.01 to the power, to a large power, would be very close to 0. So as you go further and further down this sum, the values will get closer and closer to 0, and it will be like adding or subtracting nothing. So that's something that you need to remember. Okay, so now I'm going to show you how to expand a binomial like this to the power of 5. So if I use the binomial theorem, I know that the first term has 5 choose 0 it will have, which is just 1. I will have the a to the power of n, which is 3 to the power of 5 for me, and b to the 0, which is 2x to the 0, which is going to be 1. So all I'm going to have left is 3 to the power of 5. 3 to the power of 5, I can write that here, plus, now I'm going to have 5 choose 1, I'll write that one down, 5 choose 1, times 3 to the power of 5 take away 1, which is 4, times 2x to the power of 1. Next term, I will have 5 choose 2 times 3 to the power of 5 take away 2, which is 3, times 2x to the power of 2. Next term is going to be 5 choose 3 times 3 squared times 2x to the power of 3. And then the next term is going to be 5 choose 4 times 3 to the power of 1 times 2x to the power of 4. And the last term, I know 5 choose 5 is 1, but I will write it here. 5 choose 5 times 3 to the 0 times 2x to the power of 5. Okay, so now I'm going to try and simplify this. 3 to the power of 5, that is 243. So I will have 243, and 5 choose 1, this one's 5, times 3 to the power of 4, 3 to the power of 4 is 81. So I will have 5 times 81 times 2x, because 2x to the power of 1 is just 2x, plus, now 5 choose 2, this one I'm going to use the factorials. You could use your calculator here, use the Ncr function on your calculator, but I'll just work it out. So I'll have 5 factorial over 2 factorial times 5 take away 2 factorial. 3 cubed is 27, so 27 here. And 2x squared is 2x times 2x, which is 4x squared, times 4x squared, plus, okay, 5 choose 3 now. I'm going to write it out like this. So I'm going to have 5 factorial over 3 factorial times 5 take away 3 factorial times 3 squared is 9 times 2x cubed is 8x cubed. Okay, next one, plus 5, choose 4 now, so 5 factorial over 4 factorial, and then 5 take away 4 factorial, times 3 to the power of 1 is 3, times 2x to the 4, that will be 16x to the 4, plus last one, so 5 choose 5 is just 1, 3 to the power of 0 is 1, so all I will have is 2x to the power of 5, and that will be 32x to the power of 5. So what I need to simplify, I've got 5 times 81 here times 2. I have this fraction here that I need to simplify, times it by 27, times it by 4, and the same here, and I've got one here as well. So let's go again. We have 243 plus, so here 5 times 2 is 10, and 10 times 81 is 810. So I will have 810x plus, okay, so here I will have 5 factorial. 5 take away 2 is 3 factorial here. So 5 factorial and 3 factorial. What I will have left is 5 times 4 at the top, because I will have 5 times 4 times 3 times 2 times 1. And here I've got 3 times 2 times 1. So at the top I will just have 5 times 4, and this will cancel with that. Then I will have 2 times 1 at the bottom. So if 5 times 4 is 20, 2 times 1 is 2, 20 divided by 2 is 10. Okay, so let me just write some of that down. I'll cross it out here. So this will cancel with that one and leave me 5 times 4. 2 factorial is just 2. So 2 can cancel with the 4. Or I can say 5 times 4 is 20, divided by 2 is 10. So this whole thing becomes 10. 10 times 270 is 10 times 27 is 270, and times that by 4 we will get 1080. So 1000, I'll use black again, so 1080 x squared. Okay, so next one now, this one here. So again, can you see I've got 5 factorial and 3 factorial here. So again, these will cancel and leave me 5 times 4 at the top. 5 take away 3 is 2, so this will be 2 factorial. So it's really the same as that one. And if you remember, Pascal's triangle is symmetrical, so we should really get the same thing here. So this is going to be 10 as well. So 10 times 9 is 90. 90 times 8 is 720. So 720 x cubed. This one also, by symmetry, I can say it's going to be 5. Or I can think of it like 5 factorial and 4 factorial will cancel out and leave me a 5 at the top. 5 take away 4 is 1. 1 factorial is 1. So this is just 5. 5 times 3 is 15. And then 15 times 16. We'll work that one out. So 15 times 16. 15 times 10 is 150. And 15 times 6 is 90. 150 add 90 is 240. So 240 x to the power of 4. And the last term I already have here, 32 x to the power of 5. So plus 32 x to the power of 5. So the expansion, the full expansion of 3 plus 2x to the power of 5 simplified is all here. Here are some questions for you to do. So you need to expand these binomials with these powers. Then you have to find only the first 5 terms in ascending powers and or up to the x to the power of 4 term. So of this one here. And finally you have to use a suitable substitution and your answer to part A to estimate the value of 0.99 to the power of 8.